Hello everyone. Welcome back to the AWS VPC creation playlist. So today we will discuss the elastic load balancer and learn how they help us to achieve high availability for our applications. So without any further delay, let's get started. Okay, so today we will see how we can achieve the high availability by implementing the elastic load balancer step by step. So let us go ahead and set up the load balancer to see how we can actually high availability in action. So refer this diagram. If you see here, user is sending request to access our applications, which is present here, and the load balancer in between. Send this request from user to one of our EC instance, which is present in, be it in availability zone 1 or be it in availability zone 2. Okay, I hope that is clear. So what we will do today, we will implement all this environment. We will create all this infra. We will create two EC2 instances. We will launch them in availability zone 1 or in availability zone 2. We will create one target group. We will attach these targets under this target group. These targets are nothing but our EC2 instances, which we will launch in availability zone 1 or in availability zone 2. And we will set up the load balancer. So we will see how this load balancer send traffic to our targets which are registered under the target group. So let us proceed. So let us create these two EC2 instances quickly. Okay. So click on the launch instances button. I'll name it as an test instance, maybe 01. Okay, I'll keep other things as it is for now. We'll use the default one. Okay, so here we do not have key pair, I guess. Okay, so we'll create new key pair. Okay, we will name it I'll be test key pair. Okay, click on the key pair button. I will quickly move it to our desktop. Okay, perfect. So now next thing is network settings. We will go ahead and we will edit these settings. As we are using the default VPC, we will keep as in default VPC here. Under the subnet option, what we will do, we will launch this instance in US East 1A availability zone. I will select the US East 1A here. Auto assign public IP is enabled. So now we will create one security group. So I will name it as an test security group. Okay. So here if you see we have SSH inbound entry in or security group. So while creating this security group, it will attach or it will insert the SSH entry in inbound rule, which will use the port 22. Okay, so we will keep other settings or other things as it is. I'll quickly launch it. So we have successfully launched the instance 1, which is our first instance. We can say this is our first instance. We have launched this instance. So now what we'll do, we'll quickly create a second instance as well. Okay, click on the launch instance, tests, instance O2, key pair. We just created the key pair. We'll select same key pair. Then we will edit the network settings. Now here, the second instance we will launch in the US East 1B availability zone. Auto sign public IP is enabled. Here we will select the existing security group, which we have created just 2 minutes ago. Name is test security group. And other things we will keep as it is. Okay, so I will launch this EC2 instance. So now we have launched two EC2 instances. We have launched first EC2 instance in US East 1A availability zone and second EC2 instance in US East zone B. In our case, first one is availability zone 1, second one is the availability zone 2. So this much is done right. I hope this is clear. Okay, as now we have created these two EC2 instances. What we will do, we will quickly log into both the EC2 instances and we will install Apache server on it. And we'll add one HTML in on both the servers so that we can access those from browser. Okay, so SSH, I think test key pair. Okay, EC2 user at the rate. Let's grab our EC2 instance, public IP address. We'll log in into the test instance 01. Let's see, now we're able to log into the instance 1. Yeah, so we logged into the instance successfully. Now I quickly install the Apache server on it. Okay, so we have installed Apache on instance 1. So quickly paste one HTML here. So we'll create oneindex.html here, okay. And I'll add some dummy HTML code inside in this particular HTML. Okay, this is clear. So now what I will do, I will just make sure I will add some clear message here. So this is simple HTML web page from, we will say server 1. Okay, so we are done with this instance. So now we will log into the second instance and we will follow the same steps. So on the second instance as well, we will install the Apache and we'll add the index.html, which is dummy index.html. So sudo vim index.html here as well. I will add some custom message. So we will say this is simple HTML web page from server da. Okay, so we are done with both the instances. So we can say, or for our understanding, we can say, though we have done these steps manually, we can say we have deployed our application on both the servers or both the EC2 instances. In future, we will do this stuff automatically where we call it CI/CD. But for now, for understanding purpose, let us imagine that we have deployed our application on both the instances. Now let us go ahead and let us create the elastic load balancer. So in the left side, we will able to see this load balancer option. So click on this, create load balancer. So here we are going to create application load balancer. There are different types of load balancer: application load balancer, network load balancer, gateway load balancer. But today we will focus only on the application load balancer. In next or in tomorrow's video, I will tell you the differences. What is difference between application load balancer and network load balancer and the gateway load balancer. So for now, let us imagine, or let us understand one thing. So application load balancer supports HTTP and HTTPS requests. So this is suitable for us. So that we are going to create application load balancer. Okay, so click on the create button. We will name it as an test load balancer. Okay, so scheme should be internet facing as we will be requesting it from outside world. So now if you see load balancer IP address type, must be IPv4 as we are going to IPv4 only. If you see under the network mapping, we have to select the VPC. We will select the default VPC here only. So now if you see, we are able to see here all the availability zones under this VPC or under this region. So now we have launched EC2 instances in availability zone 1 and availability zone 2, which is nothing but US East 1A and US East 1B. Okay. So we have selected both the availability zones over here, and inside that availability zone, we do have our instances up and running. We will see it in action. Now we have to select security group. So we have selected this test security group. Here, I will select test security group. So now what is listeners and routing? So here we need to select the protocol and port on which port our load balancer will listen the user request. So if you see here, user is sending request to our load balancer, but on which port our load balancer will listen this request, we will select that particular port here. So for now, we will keep the port AURA as it is. Maybe in future or in your organization, when you work on any particular project in real time, you might have to use some different port. Any port you can select here. We have certain range of ports given here. So for now, we will use the 80 port only. So now, what is happening here? The user is sending requests to our application load balancer. And then this load balancer routes this particular request to EC2 instances. So these are our EC2 instances. So we can say load balancer sending traffic to our targets, which is target 1 and target 2 in our case, which are present in target group. So here, load balancer is listening request on port 80, and it is asking us where you want to forward this request. So we want to forward this request to this particular target group, and under this target group, we will register our targets, which are nothing but our EC2 instances. I hope this is clear. So let us go ahead and create target group. So basic configuration. So we have to select target type. In our case, target type is EC2 instance. See, we have two EC2 instances. So we can say our target is EC2 instance. We can select other options as well for different purposes. Let us say IP address, Lambda function, or application load balancer. We will give it a name, test target group. So now again, we will select 80 port only here. So we will keep 80 port as in by default port here. So ideally we can say our load balancer is listening request on port 80. Also, when it sends traffic to target group. Our target group also listening on port 80 only. Okay, so next option is address type. So we'll keep IP4 only. Now VPC, we will keep default VPC as it is here. Maybe from tomorrow's video, we'll create our custom VPC and we will implement the same stuff on our custom VPC. We will keep protocol version as an HTTP1 and other options are as it is. So I will click on the next. See now what we are saying. Our target group is listening on port 80 and we have to register targets under our target group. So if you see here closely, we are simply registering these targets under this target group, okay, which are EC2 instances in our case. So just select those EC2 instances, click on include as pending below, and create target group. So now, if you see, we have created these EC2 instances. We have created this application load balancer. We have created this target group, and both the instances are present in different availability zones. Availability zone 1 and availability zone 2. In our case, US East 1A and US East Yin B. Okay, so hope we have created all this infra perfectly. So let's see it in action. So now we just created the target group. We'll select this target group. Here, now create the load balancer. So I have selected the test target group here and keep other options as it is and click on the create load balancer button. Okay, so this is our load balancer. See, this is our load balancer and this is our target group. If you select the target group below the load balancer, so this is our target group. If you select the target group, you will see we have 0 healthy instances and 0 unhealthy instances. So if you go a little below, you can see the health status of these two targets, which is still at initial level. So it will take some time and then it will check all the ports. And behind the picture, health checks are used to determine whether a target is healthy or unhealthy. It will make request our EC2 instances, which are our targets. These health checks are based on protocols like HTTP, HTTPS, or TCP, and you can define criteria such as paths, timeouts, and response codes. And it will make healthy instances or unhealthy instances based on response it will get. So let us see one more thing here. So as our instances are listening on the port 80, if you see under the load balancer details, it is saying our instances are not reachable. What is the reason for this? Because in our EC2 instances security group, we have only SSH entry or SSH inbound rule. So quickly, go ahead and add the port 80 inbound entry there. So where's the security group? Here we have selected the test security group, and here we have to edit the inbound rule, and we need to add the port 80. Inbound rule here, we need to add inbound rules in an AWS security group to define which incoming traffic is allowed to reach instances, resources, or targets in our case. So anywhere from IPv4. Save this. Sounds great. Okay, let's check the load balancer again then. See now, there is no not reachable error here anymore. And we can check our target group again. So inside the target group, if you see, it is showing we have 2 healthy instances. And also, if you see health status for both the instances is healthy. So now as we have created all this infra, and we can say we have successfully implemented our load balancer. So let's go ahead and let's see it in action. So how we can access our application via load balancer. So let's go to the load balancer and let's select this DNS name. I'll just quickly open the incognito window and I'll try to access our load balancer DNS name. It is loading. Okay. So as we are using HTTP protocol, it is just saying it is not secure. Let's click on the continue to the site. See here. Now we are getting our response from server 1. If I refresh the page, see now it is serving us from the server 2. If I reload it again, it is serving us from server 1, server 2, again server 1, again server 2. So we can say we have successfully implemented the application load balancer here. Now in our case, all the availability zone are up and running without any issues. We have created 2 EC2 instances and 2 availability zones, and both the ages are working perfectly. So both the availability zones are running, both the availability zones are up and running without any issues. So load balancer is distributing traffic or distributing our request in round and robin fashion in between the 2 availability zones. If you see first request is getting served from server 1 and second request is getting served from the server 2. So we can say load balancer is distributing the request in round and robin fashion between both the availability zones. So now as we know, each region typically has at least 3 availability zones where physical servers and hardwares are present. Some regions may have more availability zones. Each availability zone is isolated from the others with its own power supply, cooling, and networking. So what does isolation or isolated means? Isolation means if any issue occurs in one of the availability zone, let us say the power failure or any natural disaster, the other availability zone is in the same regions remains unaffected. So in case of an availability zone failure, our application or software should remain unaffected and stay up and running. So this is where high availability comes into the picture. So let's go ahead and let's see how we can achieve the high availability here. So let's refer our diagram. So if one availability zone is experiencing the failure due to power issues or natural disaster, our application remains accessible to users with minimum downtime. If one of the availability zone goes down, the load balancer will automatically route the request to the healthy EC2 instance or target in availability zone. Okay, let us see this practically. Okay, so what we are saying, let us say what we will do, how we will achieve the high availability here. Let us imagine we will terminate our first instance, or we will stop our first instance by considering or by imagining that our first availability zone is down due to any reason or any power failure or any natural disaster, maybe any cooling or networking issue. Okay, so let's go ahead and let's stop our first instance. We'll stop our first instance. So now if you see, we have stopped our first EC2 instance. It is in process. It will take some time. I'll just refresh the page. Now if you go to our application URL, where we will try to access our application by creating a scenario where we are considering our first availability zone is down by stopping our first instance from first availability zone. So I will go ahead and I will reload the application. So if you see, now our requests are getting served from server 2 only. In case of any failure, our application is unaffected and it is up and running. So we can say we have achieved our high availability here. Perfect. So if I keep reloading my window, if you see, my every request is getting served from the server 2. If you see here under the target group, we will able to see only one healthy instance because we have stopped our other instance. See, so here we have only one healthy instance, that is what load. Balancer is serving from server 2 or from healthy instance only. I hope that clarifies things. Next, here if you see at the bottom, see this target, which is nothing but EC2 instance in our case, is unused or unhealthy because we have stopped our instance. So I hope this is clear. So what we will do, we will quickly revise whatever we have learned so far. So we have created two EC2 instances as per the diagram. We have created two EC2 instances in two different availability zones. Okay, so these are our two EC2 instances. Then we created the load balancer. We set it up successfully. Then if you see here, we have created this load balancer. So we have created this load balancer here. Under the load balancer, we have created this target group. If you see here, under the load balancer, we have our target group. So we have created target group here. So here is our target group. And under the target group, we have created our targets, or we have attached our target, or you can say we have registered our targets. Our targets are nothing but our EC2 instances. So the flow works like this. User request to the application balancer. Request comes here, then application. Balancer redirected to the target group, and target group has registered targets inside it, which are EC2 instances in our case. Okay, so now one more thing I just want to cover here very quickly. So as I mentioned, the load balancer distribute request in round and robin fashion, like first request was getting served from the server, 1 second request was getting served from the server 2. But what happens if user accidentally reloads the page? You have probably seen message on payment. Page is saying do not refresh the page. This is because refreshing can lead to issue like duplicate transaction or transaction failure if user request get redirect to the other instance. So let's say user accidentally reloads the page, and as we mentioned, load balancers serve request in round robin fashion. So after reloading page accidentally, so next request will go to the other server. So in this scenario, we have one feature which AWS provide us, which is stickiness. So stickiness ensures that a user requests are always redirected to the same server, even though the load balancer is distributing traffic across the multiple servers. So stickiness will always ensure that users request, though a user reloads the browser accidentally. In that case as well, the user request will redirect to the same server for that particular session. So without stickiness, user might encounter issues with their session data lost, or they have to re-authenticate when switching servers. And this isn't a great experience, or I would say this is not good user experience. So let us see how we can allow the stickiness. So let us go to the target groups. So what I will do, I will just edit target group attributes here. So if you see here, under the target group, you will able to see this stickiness option. So if you select this checkbox, so we can say now stickiness is active for our load balancer or for our target group. So in that case, we can select stickiness duration. Let us say we can select for 1 hour, or we can select it for days, or we can select it for seconds. So this is how stickiness help us to redirect user on the same server in case even if he reloads his browser accidentally. Okay, I hope this is clear. Now one more thing you will ask me, or you might think how many listeners or target groups we can add to the load balancer. Okay, to answer that question, let me show you an AWS service quota basically. Okay, let's go here. Let's search for the service quotas. I will show it quickly. It will take hardly 2 minutes. So if I search here, load balancer, elastic load balancer, you will able to see here multiple options. Let us see, first thing is application load balancer per region. So how many load balancer we can create per region? So the soft limit is 50 or the upper limit is 50. And adjustability is account level. So we have two types of adjustability. One is not adjustable, one is account level. So what is account level adjustability here? So let us say AWS is saying maximum you can create 50 load balancers per region, but we can request for more. So we can make requests to AWS by saying that we need more load balancer per region. So this is how AWS can allow us to create more load balancers per region. So this is account level thing. Second is not adjustable. So this is, we can say soft limit, and this not adjustable option is hard limit. So let us say conditional values per rule, or conditional wildcard per rule, or let us say any kind of limit or any kind of hard limit. AWS is clearly telling us we will not allow to create the resources more than we have provided. So this is hard level, hard limit. We can create this much of resources only. We can see few more options. See this, target groups per application load balancer. So per application load balancer, we can create only up to 100 target groups, and this is not adjustable. So what does that mean? We really cannot create more than 100 target groups per application load balancer. So I hope that's clear. So yeah, that's it for today. In the next video, we will create our first VPC step by step. Don't forget to like, subscribe, and hit the bell icon for the updates. Feel free to drop any questions in the comments. I will happy to help. Thanks for watching. See you in the next video.